Hi everyone. Alright, we're going to go over 9.2 significant test population proportion. So we're going to call P sub O our population proportion, assuming our null hypothesis is true. And we're doing this because that's the whole point of a significance test, is to see if we actually believe the population proportion. Alright, so our conditions are random, okay? The data came from a well-designed random sample or randomized experiment. And mind you that we do random so that we can find the center, which is mu. Okay? Then we check independence. This is our 10% condition. Okay, and this gives us our spread, which spread tells us our standard deviation. Okay, and then we have normality, or large counts, and we get n times p sub o, greater than or equal to 10, and n times 1 minus p sub o is going to be greater than or equal to 10. And then we can find the shape. This gives us our probability. So this is why we do the things that we do. Okay? Alright. So here we go. We're going to do some calculations. Alright? So significance tests, they use a statistic. And so we calculate that from a sample. So this is like with the Skittles. What we're going to do on Mondays, we're going to look at the fact that 40 out of the 110 Skittles that we tried, we got right. Alright? And this is compared to the population, or our P sub O. The goal is to assess how far and in what direction the statistic is from the parameter, standardize the statistic. The standardized value is called the test statistic. We do the statistic minus the parameter over the standard deviation of the statistic. Alright, our four-step process that we went over and have been going over is that we state what hypothesis or hypotheses do you want to test, and at what significance level we're defining any parameter. Okay, so this is where you're going to give your P. Okay, you're going to give your H sub O, your H sub A. And we're going to give our alpha, our significance level. Alright. So now we plan. We choose the appropriate inference method. And we check our conditions. Okay, we just went over our three conditions. We got random, independent, and normality. Alright. If the conditions are met, we perform the calculations. We compute the test statistic and find the p-value, the probability that you get something as extreme or more extreme, and then we make a conclusion about the hypotheses in context. Make sure that you are putting this back into the context of the problem. So we are doing a one sample z-test is what we use and have been using. Alright, suppose the conditions are met. So supposing that you found that it was random, that it was independent, that it is normal, we want to test that H sub O equals of P equals P sub O and compute the statistic. So remember that we're taking our statistic, we are subtracting our parameter. Remember, the statistic is the number that describes the sample, so that is our P hat. Our parameter is going to be our P sub O, because this is the number we believe to be true about the population until we either reject or accept. We fail to reject or reject. Okay? Remember, we're not accepting the null hypothesis. Alright? We divide that by the standard deviation of the stat, and when we do that, that's our standard deviation is P sub O times 1 minus P sub O over N, gives us our standard deviation of P hat. Alright, so we have to find the p-value by calculating the probability by using a normal distribution in the direction of H sub A. So, first option is if H sub A with P greater than P sub O. This is a one-sided, okay? We don't have to multiply. But I want you to get into the habit of labeling your mu, okay? Which is equal to P. And then you also need to label where your P hat falls. But you do that where the z-score tells you to. Alright, and then we're going to shade, and the p-value is equal to the area here. And you also need to make sure that you're labeling your standard deviation. Okay? This is what we have to do in order to show that we could find the probability the way that we found it. Okay? Your second option is if your alternative hypothesis is that if P is less than our P sub O. Okay, so if the true proportion really is less than the parameter that we know. So we would do the same thing. So here's our P hat. It's where Z would fall. And what I mean by that is you're going to look and see, like, is it 1 standard deviation, 2 standard deviations, etc., etc. Label your mu equals P. In this case, it's our P sub O. And then we have our standard deviation. Okay? Alright, and then our third option, so these were both one-sided. Our third option is two-sided, and it's when our alternative hypothesis is P does not equal P sub O. And that's whenever you have both sides, and we shade them both in. Okay? Here's our mu, we got our standard deviation. Okay? We got our negative z and our positive z, and you have to multiply the area of one side by 2 to get the p-value. Okay? Alright. So let's look through a problem, okay? So, back to those potatoes. Glorious potatoes. Alright, 1 potato, 2 potato. The potato chip producer from earlier has just received a truckload of potatoes from its supplier. Recall that if the producer finds convincing evidence that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes from the truck. An inspection reveals that 47 of the potatoes have blemishes. Carry out a significance test at the alpha equals 0.05 significance level. What should the producer conclude? So, the first thing we're going to do in our 4-step process, so we have to state. So our H sub O is going to be P equals 0.08. Because this is our null hypothesis. Our alternative hypothesis, we'll send them away if it's greater than 0.08. Okay? We have P is the true proportion of potatoes with blemishes in the shipment. And our alpha level that we are testing against is 0.05. So we have stated our hypotheses, our parameter, and our significance level. So now we need our plan. And the test we're going to use is a one sample z-test for proportion. Now we got to check our conditions. Our first one is random. And it says it's a random sample, so even though we don't have like a sentence we have to write out, we do need to state that we know that it's random. The second one is independence. That's our 10% condition. So we have 10 times n has to be less than or equal to our capital N. 10 times 500 is equal to 5,000. So we assume at least 5,000 potatoes in the shipment. And our last condition is normality. So we have our large counts condition. So you have n times p greater than or equal to 10, and n times 1 minus p greater than or equal to 10. We have 500 times 0.08 is equal to 40, which is greater than or equal to 10. And then we have 500 times 1 minus 0.08 equals 460, greater than or equal to 10. So it is approximately normal. Okay. So we have stated, we have planned. Now it's time to do. Sorry, that cut off there. So we have our do. Alright. So p hat is equal to 47 of the 500, or 0.094. Running out of space and time, so hopefully we can finish this quickly. Now our z, if we want to find our standard deviation of p hat, if you like using the normal CDF, the way we have been, it's going to be equal to 0.8 times 1 minus 0.08 over 500. If I type that in the calculator, get 0.08 times 0.92 over 500, take the square root of that, 0.012. Okay, our z value is going to be our p hat minus our p sub o over our standard deviation here, so we get 0.094 minus our 0.08 over 0.012. Alright, I'm going to pause here just because it's going to time me out, and I'll be right back.